students. Today we are going to see the topic system of linear equations in three variables using matrix. System of linear equations in three variables. So what it means is we have three variables or three unknowns and three equations, and how to solve those equations for values x, y and z or any other variable using matrix. Okay, so let me write three equations first. a1x plus b1y plus c1z equal to d1. Similarly, a2x plus b2y plus c2z equal to d2. a3x plus b3y plus c3z equal to d3. Here we have three equations and we are going to use matrix to solve these equations. Right? So, in order to solve using matrix, first we should represent these equations in matrix form. So, I am writing this as matrix of a1x plus b1y plus c1z, a2x plus b2y plus c2z, a3x plus b3y plus c3z equal to matrix of d1, d2 and d3. Now I am going to split x, y and z and a1, b1, c1 and these coefficients in two matrices. So I am writing this matrix is split into two, a1, b1, c1, a2, b2, c2, a3, b3, c3 into x, y, z. Now see, this is 3 by 1 matrix and here 3 by 3 into 3 by 1. So result is 3 by 1. When you multiply, you get this value. Right? a1x plus b1y plus c1z first. Similarly, a2x, b2y plus c2z. So I am splitting this into 2 and I am writing this as d1, d2 and d3. Okay, this matrix is nothing but coefficient matrix. I am naming this matrix as A. This is coefficient matrix and this is variable. So I am writing x and I am naming this matrix as B. This is constant matrix. Constant matrix. So I am writing this as A into x equal to B. Now pre-multiply by A inverse Ax equal to A inverse B. A inverse A is I into x is x. So I am writing this as x equal to A inverse B. Right? This is the value for x, y and z by using matrix method. So we need to find A inverse and multiply with B matrix. Right? I am writing here further x equal to A inverse B, which can be again written as, what is A inverse? 1 by determinant A into adjoint A. So I am writing this as 1 by determinant A into adjoint A into B. Right? So this x y and z variables can take any value, and based on its consistency, this system of linear equation can be split into different categories. So I am writing this as simply Ax equal to b, which represent this equation here, right? This is split into mainly two categories. One is non-homogeneous, which means b is not equal to 0. What is b? Constant matrix. When the right hand side of this equation becomes 0, then this is homogeneous equation, right? We already know this. So when b is not equal to 0, these equations are non-homogeneous. What is homogeneous? Degree of all variables is same. And the other option is homogeneous, which means b is equal to 0. Here we have two cases when the equation is non-homogeneous or homogeneous. Okay, when the equation is non-homogeneous, it can be further split into different categories. One is this equation can have unique solution. Unique solution, or no solution, or infinitely many solutions. These are three cases possible when the equation is non-homogeneous, because when the equation is homogeneous, either all these are equations of plane. So these planes can intersect at a unique point, or these planes can overlap. That means infinitely many solution, or these planes do not intersect. That means parallel planes. So then the equations have no solution, right? And the second case is homogeneous. For homogeneous equation, this will always have solution. So when the equation is homogeneous, then we can have trivial solution. That means unique solution, and the solution is 0 or non-trivial solution. Okay, so these are the possible outcomes or ways in which this equation can have solution, right? So when the equation is non-homogeneous, that means, see from this equation, when the equation has unique solution, that means obviously determinant not equal to 0. So this is determinant A not equal to 0, and adjoint A into B can be 0 or non-zero. That doesn't matter, because when determinant A is not equal to 0, this represents some value divided by some value. So this will have unique values, right? So this will have unique solution. For no solution, determinant A equal to 0, denominator is 0, and numerator is non-zero. That means some number divided by infinity means we don't have, some number divided by 0 means we can't say it as any finite number. So this is for second case. So adjoint A into B is not equal to 0. represents the solution here when you divide by determinant A. But now we consider determinant A as 0. So adjoint A into B, when it is non-zero, then X matrix will have at least some number as infinite. So there is no solution, right? And for this case, infinitely many solution, again denominator should be 0 as well as numerator should be 0. That means determinant A is 0 and adjoint A into B equal to 0. But this is not enough to say if the equations have solution or not. This case have may or may not be consistent. This is not sufficient because we need to substitute and see. So we have to use determinant method. What we learned the procedure in determinants, we have to use it. Just substitute one variable is equal to t and solve for two equations, and then substitute in the third equation and see if this values is satisfied or not. Only then we can say if this equation is has many solutions or no solution, right? So this is the case here. Next, for trivial solution, that means observe here unique solution and determinant B matrix is 0. So adjoint A into B is always 0, and we need unique solution. That means determinant A not equal to 0. Then all the values will be 0, right? So here determinant A is non-zero. Obviously, for non-trivial solution, determinant A equal to 0. Then we have 0 by 0 because this is 0 for homogeneous equation because matrix B is 0 matrix. So 0 by 0 is we have infinitely many values. It can be any value, right? So this is the overall cases possible to solve system of linear equation using matrix. Okay. And this procedure here, this is devised by Gauss Jordan method. This is given by Gauss Jordan method to solve system of linear equation. He has given this formula x equal to a inverse into b. Okay. Okay, now we will try to solve problem for this. Question is, we are given matrix 1 alpha square alpha 1 alpha square alpha 1 into x y z equal to 1 minus 1 1. For the above system of linear equations infinitely many solutions, and if infinitely many solutions are possible, find the value of 1 plus alpha plus alpha square. Right? This is our question. You understand what the question is? For the given system of linear equation, these are linear equation in 3 variable x, y and z. Infinitely many solutions are possible. Right? So now we need to find the value of 1 alpha and alpha square. So when infinitely many solutions are possible, that means obviously this is what 1 by determinant A into adjoint A into B. That means when you have infinitely many solutions, then determinant A is 0. Determinant A equal to 0 for infinitely many solution. For infinitely many solution. So that means determinant of 1 alpha alpha square, alpha 1 alpha, alpha square alpha 1 equal to 0. Now expand and expanding the first row. 1 into 1 minus alpha square minus of alpha into alpha minus alpha cube plus alpha square into alpha square minus alpha square equal to 0. Right? This is 1 minus alpha square plus I am taking alpha outside, so I am writing this as 1 minus alpha square can be grouped in one bracket. Then we have again same factor. I am taking alpha outside, so alpha minus alpha 1 minus alpha square after taking alpha outside. This is alpha square minus alpha square is 0. Right? This is 1 minus alpha square into 1 minus alpha square. 1 minus alpha square whole square equal to 0, which means 1 minus alpha square is 0. That means alpha square equal to 1, alpha equal to plus or minus 1. Right. So what is the case for us? Adjoint A into B is equal to 0. Adjoint A is, we have to find adjoint A and B. But when we do that, then we have big problem. I will explain why. Now, in order to write adjoint matrix, take cofactor and transpose it. So, cofactor of 1 is 1 minus alpha square. Cofactor of alpha is alpha minus alpha cube, negative sign. This is for either 1, 2, I am writing it 2, 1 after transpose. So, this is alpha cube minus alpha. Next one is plus sign. This is alpha square minus alpha square 0. Clear, students? Next one is this is 2 1 plus. So for 1 2 I am saying this is negative sign alpha minus alpha cube. That means alpha cube minus alpha. This is 1 minus alpha power 4. Alpha minus alpha cube negative. Alpha cube minus alpha. Next one is alpha minus alpha cube. Wait, here I have written something wrong. This is for 1 3 alpha minus alpha cube. Oh, sorry, correct one, 0. Okay, next one is for 3 1 alpha square minus alpha square is 0. 3 2 alpha minus alpha cube, negative sign. So alpha cube minus alpha, and 3 3 is 1 minus alpha square, positive. So this is our adjoint matrix. Adjoint into D equal to 0. Now this should be written in matrix also. 3 by 3, 3 by 1, result is 3 by 1 matrix. So when you multiply and add, this will be very big. Here we have 4 power cube, and we need to factorize and see what are the values that are possible. And even if we solve this, then there is also the solution may or may not come. So it could be infinitely many solution or no solution. So instead of doing this, I am suggesting another method to solve this. Just here we found alpha is 1 or minus 1. Just substitute alpha value here and write the equations. When case 1 alpha equal to 1. What are the equation possible? 1 1 1. That means x plus y plus z equal to, I am writing it as equation equal to 1. Next one is 1 x plus y plus z equal to minus 1. X plus y plus z equal to minus 1. Third one is x plus y plus z equal to 1. These two equations are same. That means these two equations represent same plane. But this is different by constant. So this is a parallel plane. So these two do not intersect and there is no solution, which means no solution is possible for all 3 planes. Right? This is, so we have alpha equal to 1 is not our solution. So next case is case 2, alpha equal to minus 1. So when you substitute minus 1, what are the values? X minus y plus z, x minus y plus z equal to 1. Here minus x plus y minus z equal to minus 1, minus x plus y minus z equal to minus 1, x minus y plus z equal to 1, x minus y plus z equal to 1. When you multiply this by negative, all 3 equations are same. So we only have one plane and these 3 are overlapping. So these are coinciding same point. So whatever value that is satisfied by x, y and z for this equation, all many values are possible, which means infinitely many solution. Infinitely many solutions are possible. So what is our answer for alpha? Only one value, alpha equal to minus 1, which implies alpha equal to minus 1 is our result. So what is asked here? 1 plus alpha square, which implies 1 plus alpha square equal to, substitute the values, 1 plus alpha plus alpha square. This is 1 minus 1 plus 1. Answer is 1. This is our answer. Right? This is asked in JEE Advanced. Okay? Easy question. We found the answer easily. Answer is 1. Okay. We will discuss other topics in next class. Thank you, students.